Good afternoon, dear learners. Good afternoon, dear learners. My name is Shashank Shrivastava, and I am from the School of Engineering and Technology, Indira Gandhi National Open University. Today I am going to present before you one of the topics that is called heat transfer, and it is for your course heat transfer, which comes under your MSc in Renewable Energy and Environment program. So let's start with it. Today I shall be dealing with the introduction part of the heat transfer only, so that you can get a glimpse of what is heat transfer, why we are studying that, and why we need to go into this topic. So whenever we talk about transfer, so transfer phenomena includes wide range of transfer processes. It may be heat transfer, it may be momentum transfer, or it may be mass or energy. So, usual practice to study these phenomena is on the basis of generalized fluxes and forces. So, there can be a kind of a force or flux which results in this type of transfer. So, before talking about heat transfer, like in mass transfer, we can see when is the transfer taking place. Whenever there is a gradient or a difference. So, what is the difference in case of mass transfer? That is concentration gradient. Wherever the concentration of mass is higher than at the second place, so the mass will transfer from the higher concentration gradient to the lower concentration gradient. Similarly, one very common example for us is that of current. So current flows from higher potential to lower potential. So there needs to be a potential difference for current flow. Similarly, momentum transfer occurs due to a velocity gradient from higher velocity to lower velocity. And in chemical processes, the transfer occurs due to the flux called chemical affinity. So we have seen that in various places these things are happening, that is the transfer is happening due to certain types of fluxes or forces. So similar is the case with heat also. Heat flows whenever there exists a temperature gradient. That means that at one point the temperature will be higher and at the other end the temperature will be lower. So there will be a difference between the two temperatures, and that will be called the thermal gradient. So then heat flow can take place. Otherwise heat flow cannot take place. So when we talk about heat transfer, what is the aim of actually studying heat transfer? Heat transfer is the energy interaction due to a temperature difference in a medium or between media. So whenever we have just now seen in the previous slide also, whenever there is a temperature difference or a thermal gradient, then heat transfer takes place. So heat cannot be stored. It's not a storable quantity. It has to flow. So there needs to be a thermal gradient, then only heat can flow, but it cannot be stored, and it can be defined as energy in transit due to a temperature difference. So primary aims of studying the science of heat transfer, what are the primary aims? To understand the mechanism of heat transfer processes and to predict the rate at which heat transfer takes place. These are the two most important things. That's why we are studying this subject. We are going into the topic of heat transfer, and whenever we refer to heat transfer, we actually imply the heat transfer rate. So I want to give you a glimpse of the practical applications of heat transfer, and it will be much better for you to understand and then go into the depth of this topic. And there are various applications you can find in nature as well as in industrial process, in both, like in climatic changes. Like you see, there are seasons throughout the year. There is the spring, there is the autumn, there is the winter and summer, and all these seasons, why they are taking place? Actually because of this heat transfer only phenomena. This heat transfer phenomena results in that. Then there is the rain. Why is the rain taking place? See, whenever the water from the sea evaporates, when heat falls on the, or you can say the sun energy falls on the surface of the sea, that water evaporates, and after evaporating it forms clouds, and at a certain point of time these clouds pour down the rain. So that rain process also involves the heat transfer phenomena. Similarly, snow. Whenever you see that when snow is melting, we feel colder. Why it is happening? Because to melt the snow, certain amount of heat is required, and that heat is going from the surroundings to that snow, and it melts, but the surroundings temperature drops down because the heat is growing from there, so we feel colder. So in all these phenomena, you can see that heat transfer is occurring. Then the heating and cooling of the Earth's surface also involves this. Then drops of fog or dew drops, these are also formed due to the heat transfer phenomena. Even the forest fires, like 2 years back or 1 year back, we had seen such a huge forest fire was there in Australia. So this forest fire is also a case of a heat transfer phenomena. So we can see in nature, in our practical scenario, how heat transfer phenomena is affecting the things. And we very well know it's a very common thing, a common sense thing, that existence of all living beings is possible due to the existence of the sun, because the sun is the main source of energy. And what kind of energy it is giving to us? It is giving us heat. Okay, so that's why heat transfer is so important. So I enumerated to you some of the applications of heat transfer. Now I am going to enumerate certain applications which are seen in the industry. Okay, before that I told certain natural phenomena, and some more natural phenomena I will tell you, but before that let's discuss about the this industrial type of things. So there are certain designing of energy conversion devices. So various devices are there, like steam generators are there, the turbines are there. So people who are from the mechanical background can appreciate these things, turbines, then internal combustion engines. And for those who are not from for that background, suppose BSc people are also studying this course, so I am just going to give you a little knowledge about this. So internal combustion engine is also known as the IC engine, and it is very commonly used in our automobiles which you drive, like your motorcycles are there, your cars are there. In all these types of vehicles we have the internal combustion engine. And in internal combustion engine there is a certain process taking place, that is we have got petrol or diesel. Okay, so petrol is used for auto cycle. There is one cycle known as auto cycle in internal combustion engine, and for the diesel one, we know diesel fuel is used. It is very commonly named and is used. So we are using that thing. And what happens that this chemical is being transformed into chemical energy is being transformed into mechanical energy. There the piston and crank cylinder mechanism is there. The piston moves inside the cylinder and it generates energy. Okay, and it is further converted into mechanical energy in case of the internal combustion engine. And there also heat transfer phenomena is taking place, because see, in auto cycle there are four types of processes. First of all, suction is there, then the compression of that particular fuel takes place, which takes place in an adiabatic manner, that is isentropic compression is taking place. Then at constant volume the combustion takes place. So whenever the combustion phenomena is coming in, that means heat transfer is occurring. After that, expansion takes place. In expansion, what happens? Work is being done. So work is being done and we are getting that work in the form of mechanical energy. And after the work of expansion, we have finally the exhaust, that is the fuel is sent out. So the waste portion is sent out. So in that manner this auto cycle works. And in diesel cycle there is a slight difference, that the combustion takes place at constant pressure instead of constant volume. So this was about the internal combustion engine. And heat transfer phenomena, I have told you how it is occurring there, mainly during the combustion process it is occurring. And then we have the turbines. So turbines, if you know it is very well, but if somebody doesn't know, then I will tell you that turbines are used in various places, like steam turbines are there. They are used in power plants from where we are getting this electricity and all, there they are used. And then we have the gas turbines, where we use those gas turbines. Gas turbines are generally used in our aircrafts and space vehicles also. So that much important is it is gas turbine. So in gas turbine it follows the Brayton cycle. Okay, so Brayton cycle, what it is quite similar to our diesel cycle. The only difference is that the exhaust is taking place at constant pressure there, whereas in case of this diesel cycle, the exhaust was taking place at constant volume. So here also four processes are there. Isentropic compression is there, then the constant pressure combustion is there, fuel is taken in and combustion takes place. Then there is the expansion process, which is again isentropic, and then you have the exhaust which takes place at constant pressure. So that was about gas turbine. So we have seen internal combustion engine, we have seen this gas turbine, we have heard now about this jet and rocket propulsion is there. All these involve the heat transfer phenomena and steam generators as well. And another important aspect is designing of waste heat recovery devices. So wherever we are seeing that the heat is getting wasted, we try to tap the heat as much as possible and try to use them. Like we have the vapor absorption heat pump, which is used for cooling purposes. Like vapor compression system is there, vapor absorption is also there. So generally what we do that we use steam there from the boilers which is coming. So we try to extract the heat from the steam that is coming out from the boiler. So in that manner we are trying to get the energy from the waste heat. Okay. So that is one case for the heat transfer phenomena. Then we have the heat exchangers. Heat exchangers are very commonly used, and there are various types of heat exchangers with wide application in industries. Some of them are given here. I am reading out to you, like the heat wheel, shell and tube type heat exchangers are there, plate type are there, plate fin type are there, spiral type are there, and I will be showing you the figures also of these after this slide. And stationary regenerator is there, metallic recuperator is there, run around coil is there, heat pipe is there. So sizing and rating of these type of heat exchangers depends upon what type of need is there. Okay, and it requires expertise to do that. So see in the figures now. Here is one type like Jungstorm heat exchanger. You can see the hot fluid, it is shown by a dark black line, whereas the dashed line is showing the cold fluid. So hot fluid is coming from the top, whereas the cold fluid is moving from the bottom, and both are exchanging heat together. There is one heating zone and cooling zone in that. So this is one type of Jungstorm heat exchanger. For the details, you will have a whole chapter on this heat exchanger in your course, and you can further read that. And there may be further lectures on this heat exchanger in detail, but just now I am covering the top part of that, that is a superfluous portion. So I am just showing you what type of heat exchangers are there, the various figures, and what are their names. So there is one more like a storage type of heat exchanger is there, you can see here. And Rudimul heat exchanger is there, like hot gas is coming in, if you can see in the figure here. This I am showing with the cursor, and hot gas is coming in at the top, and whereas after cooling takes place of this hot air, it moves out, cooled out gas is moving out from the bottom, and at the middle portion, if you can see, there is the stationary heat exchanger. And how this is taking place, there is one more fluid, that is air is being moved in. Cool air moves from the bottom and is coming out from the top, hot air. Okay, so these two fluids, we can say, they exchange heat amongst themselves and move out accordingly according to our need. Then there is one pebble bed heat exchanger. You can see here from the elevator at the top, pebbles are there inside this type of heat exchanger, and at the bottom also they are again going to the elevator. A cold air inlet is there at the bottom, hot air outlet is there at the middle portion of this heat exchanger. Then there are pressure control connections also and ports as well. This is the pebble bed heat exchanger. Then one very common type is the plate type of heat exchanger. You can see here, there, if you can see the cursor, I am moving this thing, this is a plate. Okay, this plate, these are various plates, there are various number of plates which are being placed here, and you can see how the fluids are moving. This cold fluid is moving out from this part, and cold fluid is moving in at the right hand side where my cursor is right now, you can see here. So, and the hot fluid, you can see from the top it is coming and going down towards the bottom, and it moves out from the bottom, hot fluid out, you can see it is written there. So this type of heat exchanger is known as the plate type of heat exchanger. Then one we have got a metallic recuperator. So this one is quite similar to, like we have the chimneys in case of the boilers. If somebody or someone is familiar with the boiler system, then he or she may be knowing about the chimneys also. So it is quite similar to that, like flue gas. Flue gases are in boilers also. They move out. So flue gas is moving here from the bottom side. You can see the cursor, it is moving, and it is moving up and going out. And before that, what is happening? The cold air is exchanging the heat with this flue gas. Okay, cold air is moving from the left hand side inside this type of recuperator, and it is moving out from the right hand side, if you can see at the top. Okay, after becoming hot, so hot air to process, and this flue gas is now going as a waste gas at the top of the chamber. So this is known as the metallic recuperator. Then one more system we have, this run around coil. Here also you can see waste gas coming in, cold air going from the bottom. So all these things I am showing you just to give a glimpse. I am showing you the visuals of the various heat exchangers, and the process and the phenomena and how heat exchange takes place, the various expressions, all these things you can learn from the chapter. The whole chapter is there on this. You can learn from there, and there will be lectures, counseling sessions for you on that also, whether through Gyan Darshan or whether through a Google Meet. It can happen in both ways. Okay, so now see one more thing, that is the spiral heat exchanger. This, you can see, it is in the shape of a spiral, like a circle is there, but the circle is not getting completed, it is moving out. So this is a spiral type, and the cold thing is getting into from the bottom, and hot is moving out from the top. You can see it is moving in a spiral type of thing. Okay, these arrows are showing that thing. So this is a spiral type of heat exchanger. The name is itself giving us the knowledge about that. So these were the various kinds of heat exchangers which we saw. Now we see the industrial processes. Okay, in what way the heat transfer is affecting our industrial processes. So it is used in designing of industrial furnaces, incinerators, autoclave, etc. One more very important thing is the thermal insulation. Thermal insulation is very important because sometimes we want that our heat loss is minimal or there is no heat leak. So in those cases we use thermal insulations, because an insulator has low thermal conductivity, so it does not let the heat move out. Okay, or it doesn't let the heat move in the particular object. Both ways it can be, either moving out or moving in. So one example I can give you, like our thermos flask is there. It's a very common example we use in our everyday lives. So when we want to keep hot water inside the thermos flask and we pour it into it, we want that the water remains hot for a long period of time, say about 8 to 10 hours. Okay, so in that case there is a insulating layer inside the thermos flask. Okay, so it helps us to see that the heat doesn't move out. Heat doesn't move out from that hot water which has been poured inside the thermos flask, and it is due to that thermal insulation only. Similarly, in the cold season, the vice versa can occur. So the main objective is to reduce the heat loss or heat leak. The thermal design involves judicious changes in the constitution of insulation. What will be its size, and what material should be using in our insulation, what shape, what structure, what flow pattern should be there. All these things again are given in detail in one topic, that will be the critical radius of insulation, where we will discuss how thick the insulation should be, and there will be an expression for that also, and that will be dealt later, but it's very important and we have to deal with it very soon. Then how we can enhance the heat transfer which is taking place in our heat exchangers, or we can also use the term augmentation in this case. So the main application is in the design of heat exchangers, where the total heat transfer rate, that is given by small q, between the hot and cold fluid streams separated by solid surface is usually a prescribed quantity. The objective is to transfer q across a minimum temperature difference. This can be done by changing the flow patterns of the two streams with breaking of the boundary layer. So later we will learn, like I told you in our whole chapter on this heat exchanger, there are various kinds of heat exchangers. One classification is according to the flow also, like if there is a parallel flow heat exchanger or a cross flow heat exchanger or a counter flow heat exchanger, whatever type it is there. So depending on that, we will get the amount of heat that is being exchanged between the two types of fluids. So there are distinct methods for this heat transfer enhancement. If you want to enhance the heat transfer, there are different methods. One is the passive method, and the other is the active method, and the third one is a combined method where we are using both the active and the passive method. So what happens in a passive method? Actually, in a passive method, we are not using any kind of external energy source. It does not require any external energy source, whereas active method involves external energy input to implement. So certain examples of the passive methods are the twisted tape type, wire coil, indentation of flow surfaces, like we have got corrugations on the surface, and surface roughening also. So these are all the passive methods of enhancement of heat transfer, like you see in this particular figure. This is the twisted tape type. So the tape is there, that is marked with the arrow. Here we have got the tube. So this is the twisted tape inserted in a pipe for heat transfer enhancement. Then the active type. Active type, as the word itself shows us, the active, we are using external source of energy. So here you can see it will be very clear from this figure, because we are using here what? This plunger, reciprocating plunger. So it's like a piston. We are moving this thing. We are giving the energy to this. So this is an active type. The tube is there. The direction of flow is also shown here. But we have got a moving piston here. So that's why it's an active method with a reciprocating type of plunger. So after seeing the various types of heat augmentation or heat and enhancement methods, now let us see how our heat heat transfer phenomena is going us to help in various types of things, like in temperature control also. So there are certain areas where we need to control temperature in a very proper manner, otherwise it may result in damage. Like for example, we have got the electronic equipments, such as our personal computers are there and supercomputers are there. Similarly, the nuclear reactor cores are there, where we need to control the temperature. Otherwise, uncontrolled temperature will result in damage to that particular equipment or tool. So you see, when you open the control processing unit, that is the CPU of a computer, so you may see there very small chips are there, integrated circuits are there. So all these actually require very less amount of current and amperage, but they also get heated up. So what we need to do to prevent this heating up of that, because heating up will result in the loss of performance, as well as they can get permanently damaged. So what we can do there is that we can place certain mechanisms, like you may have seen in our CPU, there are small fans also just to cool the inside of that particular CPU. So in that manner, we are controlling the temperature there, because it's very important. Similarly, in nuclear reactors, like in our nuclear reactors, they are generally nowadays used for producing our power, or that electrical energy, like we do in thermal power stations. Similarly, now nuclear power stations are coming up. But nuclear energy is huge, and it is based on chain reaction. Okay, so if this chain reaction becomes uncontrolled, then it can be very damaging. And there have been cases, like in the Chernobyl case in Russia, it happened around 1986. So it was a huge explosion, and so many lives were lost, and so much property was also destroyed. So we have to control these things. The temperature has to be controlled. So there we are using boron rods actually. So boron rods are used for controlling the temperature, and also they absorb the neutrons. Okay, so this chain reaction is stopped, and in that manner that reaction becomes controllable instead of being uncontrollable. So these were two examples which I gave you where temperature control phenomena comes in the heat transfer process, and the cooling of high heat flux surfaces such as electronic chips in a tightly packaged set of electronic circuits is quite challenging, like I told you, because of the size limitations. But we do that, like I have told you an example. Fans are placed, small size fans are placed according to the size of the CPU. Then the temperature of the electronic chips cannot rise much above the ambient temperature, because high temperatures, like I told you earlier, drastically reduce their performance. Another one very important application of temperature control is the film cooling of gas turbine blades by routing the air through channels within the blades. So, as I told you about the turbine earlier, so the turbine blades also get heated up because of the high speed at which they are moving. Heat is being produced, and there's friction also, there is drag also, so heat energy is being produced. So we need to cool the blades, otherwise a temperature may be reached where they may melt. So how do we do that? There are certain routes created inside the blade itself where we circulate those cooling fluids, and that result in bringing the temperature down, and that way we can prevent the damage to the blades of the turbine. Similarly, bioheat transfer process, we know that our human body itself has got a certain temperature, and if it is at that temperature, then it works fine. Otherwise, we have fever. We know that fever happens, that it may go up to 100 degrees centigrade or 101 degrees centigrade, whatever. So we call that person that he has fallen sick, he has got fever. So there also the heat transfer phenomena occurs. We have to control those things. And what are the applications? Bioheat transfer include human thermoregulation, thermal surgical procedures such as microwave, ultrasound, radio frequency, cryopreservation of living cells. Cryopreservation means that preserving the living cells at a very low temperature. Cryo words means that a low temperature has to be maintained, and then thermal burn injury is also there. Similarly, in metal processing also, solidification and melting, metal cutting, welding, rolling, extrusion, plastic and food processing, laser cutting materials, all these processes involve the heat transfer phenomena. Some other areas of heat transfer applications are like power production. Earlier I have told you as well, chemical and metallurgical industries, heating and air conditioning of buildings, design of internal combustion engines, design of electrical machinery, weather prediction, etc. Then we have got the chemical processes that involves heating and cooling of materials or fluid streams in a number of steps. And one example is that catalytic air oxidation of ammonia. So today we have seen how the heat transfer phenomena affects our daily lives as well as the industrial processes. We have seen various kinds of process like the chemical process, metallurgical process, and in our biomaterials also we have seen, as well as in our computers we have seen. So we have seen various applications of heat transfer phenomena and how important this topic is, and that's why we are studying this heat transfer. So I have given a glimpse to you about the heat transfer topic. I have given an introduction to you, and further we will discuss about this topic in our Google Meet sessions, or we can take sessions in Gyan Darshan also. So thank you very much for today's session. Thank you all.
Are you a fresh graduate? Do you want to fulfill your educational aspiration by pursuing higher education in various interdisciplinary and multidisciplinary areas like environment,